this is me, Harmeet, Sales and Brand Marketing Senior Manager, TuTeck Technologies. Welcome to the webinar of Coins in Cyberspace, the Rise of Central Bank Digital Currency. Today we have with us in this webinar Prateek Banerjee, who is a seasoned IT professional with over a decade of experience. He's currently the Director of Technology Consulting at TuTeck Technologies, where he leads innovative projects. And Mehul Chattopadhyay, an accomplished senior software engineer at TuTeck Technologies, who is a tech visionary and has led groundbreaking projects like the world's first decentralized quantum-safe central bank digital currency, iOS wallet, optimizing financial transactions. So, hi guys, welcome to the webinar.
Hi, Amit. Thanks for having us.
Hi, Hamid.
So, without any further ado, I think let's just dive deep into the webinar and straight cut start the questions. So, Prateek, sir, what exactly, is CBDC? What exactly is CBDC?
Okay, thanks, Hamid. Thanks for giving me the opportunity to be here today. Well, so CBDC, first of all, let me just tell you, CBDC is the central bank digital currency, and it's a very new concept that most of the central bank of each and every country are trying to develop something around it. And it is basically the digital form of the physical currency of a country, like dollar, INR, rupee, yen. So these are all in a physical format right now, right? So these CBDC is just the digital format of all these currencies. Most importantly, these are issued by some central bank, like RBI in India. Now, obviously, you can ask them what is the difference between the Bitcoins, the cryptocurrencies, and CBDC. Okay. So CBDCs are distinct from cryptocurrencies like Bitcoin and others because they are typically centralized and controlled by a government of the central bank, which actually the cryptocurrencies are not. Cryptocurrencies are decentralized currencies. Okay. So they aim to provide the digital alternative to physical cash, allowing for, let's say, faster, cheaper, and more efficient transactions while being regulated by the central authority. Okay, and CBDCs can be used for various purposes, including the retail transactions, the peer-to-peer payments, and even potentially for large payments as well. Now, in this context, I must say there are basically two types of CBDCs. One is the retail CBDC, other one is the wholesale CBDC. So retail CBDC is basically, retail CBDC is accessible to the general public. Okay, and it can be used for everyday transactions, similar to the physical cash, as we do normally in our day-to-day life. Okay, and it's directly held and used by individuals and businesses for purchase, for purchases, for payments, for savings, whatever you say. One thing I should mention that retail CBDC aims to provide an alternative to physical cash and existing forms of digital payments. Okay, obviously offering a government-backed digital currency which is widely accessible. So this is the retail CBDC. The other form is the wholesale CBDC. Okay, so wholesale centralized bank digital currency. Now, this type is limited to financial institutions and is used for mainly for, let's say, interbank and large-scale financial transactions. It is designed to facilitate certain settlements between financial institutions, potentially improving the efficiency of wholesale financial markets, like interbank lending, like security trading, and many other institutional level transactions. Mostly, this is all about the CBDC. Okay, and this is the new concept that we at TuTeck Technology have tried to build across. Yeah, thanks.
Thank you so much, Prateek, for taking that up for us. Well, moving on, Mehul. So we got to know, what is CBDC, but Mehul, why CBDC? I mean, why is it so important?
Yeah, that's an excellent question, and I'll start with an example. So, when we do transactions day to day, right, there are a few forms that we use. The first and foremost is cash that we use. Then now we have the unified payment interface, which is UPI. We also use cards and everything else. But when you're paying by a card or when you're paying by UPI, right, your bank knows who you're sending the money to. So that's the but while you're paying by cash, the transaction remains anonymous. So the 10 rupee note that you have in your wallet right now, you're not sure whose hands it's been traded by, right? So kind of introducing the cash like anonymity while doing digital transactions is the first thing that CBDC is trying to address. And the second most important thing, and why CBDC came into the picture, is central banks spend an exorbitant amount of money just making money. So the process of making the actual physical notes, which is called minting, involves about 20,000 crores every year. And that not only includes printing, but it includes the logistics cost, transferring the money from central banks to your commercial banks that you actually use. Why not make that process digital, right? It'll save you millions. So these are the two most important points that CBDC is trying to address. First being maintaining cash like anonymity while doing digital transactions, and the second is central banks can save on a lot of money while kind of digitizing the entire money minting system.
Right, right. Thank you, Mehul, for taking that up for us. So now my viewers and of course, everybody who's watching us kind of clear about what and why CBDC, what CBDC. Prateek sir, moving on, my next question is obviously to you is what is the solution and who is the solution for?
Harmeet, the solution that we have, it's basically both. Again, as I mentioned, there are two types of CBDC, right? So definitely of course, it's a retail CBDC as well as a wholesale CBDC. It's for the public as well as for the other financial institutions, other commercial banks of the country and everyone. Now, as Mehul already mentioned, definitely one of the biggest challenge is in today's scenario where we are using physical form of the cash is the efficiency, right?
Yeah.
So CBDCs can actually streamline the entire payment system, okay, making transactions even faster, cheaper, and of course more accessible, especially across. They could potentially reduce the need for intermediaries in financial transactions. Second thing you can say that reduce. See, one scenario we never thought that even to print a 10 rupee note, government has to pay some money, right? They have to procure those papers, they have to the printing cost, everything. If CBDC is implemented, then what are the benefits? We can also reduce those costs. So digital currencies could reduce the cost associated with the printing and distributing the physical currency, potentially saving money for the central banks, because this is an area where central banks has to pay a lot. The third most important point is the financial inclusion. So CBDCs might help include individuals and businesses who are currently underserved by traditional banking systems, okay, giving them access to an entire digital form of the currency. And of course, I should say that government, it is very helpful for government as well, because CBDCs would offer central banks, RBI, like RBIs of India, okay, a new tool for implementing monetary policy, enabling better control and flexibility in managing the entire economy. And of course, last but not the least, it's a counteracting private cryptocurrencies, right? Some CBDCs as a way of governments to maintain control over the monetary system in the face of the growing popularity of private cryptocurrencies like Bitcoin and others, okay, which operate independently of central authorities. And that is the main reason in most of the countries you can see that cryptocurrencies government has not made it legal yet. Though most of the countries have accepted it as a legal currency, but there are a couple of other countries where it is not legal. But that challenge will not be in case of CBDC, because CBDC is going to be issued and controlled by the central government of that particular country.
Right, right. Thank you so much, Pratik, for taking that up for us. Moving on with the webinar, Mehul, we just got to know about what is CBDC, why CBDC, what is the solution, and who's the solution for. But can you highlight a little bit more about the tech in the application? If you just talk about the tech in the application.
So building on what Pratik said, our solution that we built was specifically geared towards everyday transactions. So right now, when you go to a kirana shop, you pay by UPI and you buy a cold drink or a piece of cake, right? And it's the same kind of solution that we wanted to implement using CBDC. So we wanted to maintain the cash-like anonymity while you're doing a digital transaction. So we simulated all of that. So all in all, we had about 6 parts to the entire application. There were 2 mobile apps that we built. The first one was for consumers, which is us, and the second one was for the merchants or the shopkeepers. And there were 2 dashboards: one for the central bank to see how much CBDC has been issued to the various commercial banks under it, and there was a dashboard for the commercial banks to see how much CBDC has been issued, withdrawn, redeemed, and all of that. And there was a backend to all of this, and there were two. Actually, the backend consisted of a blockchain called Mixnet, where we stored all of our transactions to maintain the anonymity. So that's how we maintained the anonymity. And we had a database layer of MongoDB where we stored our spent and unspent lists of coins. The entire money minting process, which we'll come to later, I hopefully, we kind of stored all the coins that were already spent by storing the serial numbers, and coins, if they had generated the same serial numbers as the one already spent, they were said to be invalid. So these went into unspent, and the coins that hadn't been spent also went into unspent. So the layer, we built our mobile apps using Swift, which is the native technology for iOS, and we build the dashboards using
Sorry,
React.
sorry,
And
you to intervene you. How was the journey during development? Because you just mentioned iOS, right? How has the journey been
yeah,
during the development stage?
yeah, so the journey was absolutely amazing because we actually did not have a lot of hands-on experience with Swift. We had experience with hybrid technologies like React Native, but we never had very we were not very skilled in Swift. So the first huge challenge was picking up Swift, and it's commonly known that it's a very verbose language, right? And it's kind of the joke going around that Swift is a very verbose language. So the first challenge was picking it up, and the second challenge was there were a few things which were quite easily done with native languages like React, with hybrid languages like React Native, pardon me. But a few things were really difficult in Swift. I remember a particular example where we were given a Go library to integrate into the iOS app, and we had to go through the entire way of getting Go to C++, C++ to C, C to Objective C, and Objective C to Swift. So that was an entire process that we had to follow. So yeah, and these problems wouldn't have arisen if the Go library would have been just a regular backend exposing a few APIs, and we could have just hit it from the application. But since we had to maintain a lot of security, we had to kind of embed that entire library into our mobile application, because all of the generation, the coin generation, the serial number generation, and all of the minting process happens on the client side. You can't have it on the back end. That kind of maintains and mimics the decentralization part of it. So yeah, the journey was absolutely amazing. I worked with a team of very amazing developers, and Pratik was obviously there to manage all of it. So all in all, it was a great learning experience. And yeah, so I think that's about it.
So Mehul, you just spoke about the iOS as a platform. So why iOS and why not other platforms?
So we initially went with iOS because we wanted to kind of use a piece of hardware in iPhones, which is called the secure enclave. So we wanted to mimic the transactions using the way that cryptographic transactions happen right now, which is you have a private key, for yourself, and you have a public key, and you sign the transaction with the private key, and it goes to the other person or whoever you're sending it to, and then they decrypt it, right? So secure enclave is a piece of hardware found in iPhones. So we can generate, if I remember correctly, 128 or 256 byte strings, which can be a private and public key, and it gives it to you as a pair. So that's kind of what we initially started with. And the second reason was we knew what our demographic was when we were trying to build the application. And we were going for central banks, and most of the users there had iPhones. And third, we wanted to make a really fluid app. And no matter what developers say, no matter what people say, the same feel of an application doesn't come when you use a hybrid technology. But when you're using native technologies like Swift, there's a lot more fluidity in the app. So I think these were kind of the three reasons we went ahead with iOS. But I hope moving forward we will think about rolling out solutions for other OSs as well.
Right. Thank you, Mehul, for taking that up for us. Mehul, why, I mean, we understood that, why iOS is chosen for the moment. Of course, we would be expanding. But what would be the high level architecture for this application?
Yeah, that's an amazing question. The high level architecture that we had thought of, and that's what we built at the end of the day, was we would have a customer facing mobile app, and I'm talking very high level here, and we would have a merchant facing mobile app. to support all of this, we would have a regular old backend, but we kind of want to mimic decentralization because we are trying to do cash like anonymity, right? And we can't know which person has sent who money, and no governing authority can see it. So we kind of thought of a blockchain where we used this custom private blockchain called Mixnet. And for the DB, we wanted to go with something that's really scalable, and we knew it was going to be much more write heavy than read heavy, because for all our purposes, we wanted to make more transactions than see those transactions at one go, right? Because a lot of people are going to make a lot of transactions at one time, but not one person is not going to read all of the transactions. So we wanted to make a use a very read heavy database. So we kind of obviously went ahead with no SQL, so we use MongoDB. So how these apps talk to the backend was the backend exposed regular APIs, like logging in, sending a transaction, and everything else. But there was a nice way of how the merchant app and how the consumer app talk to each other. So a merchant generates a QR for a new transaction, which has the amount, which has the logo of the merchant, so that it shows up on the consumer app, and all of that is embedded into the QR as a JSON. So the customer scans it with there's also the API URL for that current transaction with the transaction ID, and the merchant app continuously polled the API, the transaction or the payment API, to see if the transaction has been made. The transaction has been made. If you use the app, right, you scan it, and as soon as you pay it, like, it's almost like a real time, but in the backend it's happening like it's polling. We thought of scaling this using sending it to the backend, and the backend sending a server sentiment back to the merchant app, but kind of created a lot of overhead. So for that, we went ahead with the polling procedure, because again, one payment is not going to be made by a lot of people, so it's not a problem to continuously poll it. And we weren't very worried about a lot of people making many transactions at one time. And we would obviously we load balance them and horizontally scale them. So, and obviously we had the few analytics dashboard that was built in React, and it was directly calling the backend with a set of APIs. And the authentication here was also a fun part. It wasn't your regular old, hit it, get a JWT token, embed the user ID. It wasn't that. So we use something called Keycloak, where you could make users, and all of the authentication occurred through Keycloak. So these commercial banks and the central banks could manage the users, and even the central banks could manage their commercial banks. So all of the authentication happened on Keycloak. And once we got the user details, we went ahead with all the APIs that were exposed on our backend.
Right, right. Thank you so much, Mehul. You made it seem so simple, but I'm sure it has a lot of processes, right? Mehul, you've mentioned how the solution digitizes the money minting system, right? But how does it work in all practicality?
Yeah, I think we've reached the meat and potatoes of this entire application. So this part, I'll just say this: this hasn't been done before. This is the world's first, quantum safe CBDC app. So the process that we started with, so we used to use four different methods. So the first method is we used to generate a string that was a one-way string. You couldn't get back the coin from the string, which was the serial number. And then we used to top it off, like people can't recognize you if you're wearing something on your face, and you can change it. So we used to mask it. So we used to mask it with another number that could only be understood if you have another private key. And then we used to send that serial number over to the central bank. The central bank used to say, oh, I recognize this, and used to check the spent list if the serial number is already present in the spent list. And it used to see, no, it's not. So you know what, this is a valid coin generated by the consumer, so let's just give it back to him. So as you can see, this process does not involve the commercial bank at all. The request for a coin directly goes to your central bank, which Pratik explained. Like, it's a central bank currency, right? And it used to get signed by the central bank. Like, it puts your serial number on your note whenever you make it, and then it comes back to you. You can say, oh, the central bank signed it, so this is a valid coin, and then you just store it. So this is kind of how cash is made anyway, right? You make a note, you just have a piece of paper. On that you have a lot of things on it, like 100 Mahatma Gandhi's photo, and then like words on it, and then a serial number. You send it to the central bank. Central bank is like, yeah, this is a valid coin, this is a valid note, and it's not counterfeit. So you know what, I'll put my stamp on it, or I'll put my serial number on it, a new serial number, and gives it back to the commercial bank. So in all practicality, it works the same. In our case, we generate a serial number, we mask it with something else, so that other people in the same network can't say that this is the same coin, and then we sent it to the central bank. The central bank says, oh, this is a valid coin, signs it, sends it back to us, we unsign it, and we see if this is a valid coin. If central bank validated our coin, we don't validate it, the central bank validated our coin, and then we store it in our wallet, the app that we built.
Right. Thank you so much, Mehul and Prateek, for coming and joining us on this webinar today. Excellent webinar. Thank you so much for the great insight on the rise of central bank digital currency. If you have any queries or requirements around central bank digital currency, please talk to our experts at TuTeck Technologies. You can contact us at info@tutech.com. Please visit www.tutechtechnologies.com to know more about our services. See you in the next webinar where we dive into the quantum safe, right? And of course, can you tell us a little bit about what are we going to do with the next webinar, Mehul, before we sign off?
Okay, so the next webinar, we're going to talk to you about an algorithm that even quantum computers can't break. And that's how we managed our coin signing. Yeah.
So stay tuned. Absolutely. Stay tuned, and thank you so much, Mehul and Prateek sir, for joining us. Thank you so much.
Thank you.
Yeah. Thanks for having us. Thank you.